Right. Chaos engineering with service mesh. Well, a little bit longer introduction. I'm originally from Belgium. I've been a software engineer for like 10 years. I worked at a company like Unity, the game engine, where I used to manage the backend of the ads network. So if you have a mobile and there is game on it, there's probably a chance that your mobile phone has hit those servers. It's around 2 billion devices, 50,000 requests per second. So let's say that it was a really interesting experience. And right now I work at the Discovery as a consultant for to make sure that the people at Dplay keep watching their show and that X on the Beach gets streamed in the Nordics. So to give you a little bit of an outline of what we're going to talk to today is first I'm going to explain to you what is the birth of the service mesh, what is it, how is it our architect, and with a little bit of demo. So that's the first part. The second part will be more focused on chaos engineering and why a service mesh is really interesting for chaos engineering. Because the two both help each other, and of course we will have a demo and Q&A, but I keep that in the end. Please feel free, raise your hand. We are amongst friends here. So yeah, I have a few questions for you, so that I know what you know. Do you know what is a service mesh? Okay, so I can explain that. Do you know what is a SLI, SLA?
Only SLA.
Yeah, okay, no problem. Everything I'm going to explain to you, the goal is that at the end of this session, you will be able to understand or make informed decision about what technology you should use. And of course, you know what is chaos engineering. Yeah, congrats. Yeah, I'm glad. Did someone already did chaos engineering? You'd be surprised. I'm pretty sure that some of you did it, you didn't know it. So yeah, so as a beginning, there was, at least the version I know, is that a product manager at Google went touring in the US and Europe to see all the big clients and see what kind of problem they had. And they categorized this into 4 different, I would say, modules, because the microservice architecture is here to help you scale. You cannot have monolith once you're reaching like millions of requests per second or something like that. So you have to break down things into components and scale those components accordingly. The problem comes when those components have to talk to each other. It's really hard. So the first thing the service mesh was designed to do was to help connect those services together. Then you also have security. Who here has heard of GDPR? Look around, everybody raise their hands. So actually you might want to encrypt the traffic. Actually you are legally obliged to encrypt the traffic between your microservices. The second thing is control. If you release a new version and you want to test it out, you might want to release a canary release, but the problem is how do you redirect the traffic, like only a small percentage of the traffic to that new version without breaking the whole thing down. And so you know what they say is that the difference between software engineering and programming, does anybody know the difference? No? Okay, so software engineering is programming when you add people and time. That's basically the idea. The more your single program is easy, but over time and with more people contributing to it, it becomes really hard to manage. So those releases might seem very simple on a conceptual level, but they are actually really hard to do. And the second thing is, how do you debug those microservices? Like, what do you know? How do you know what happened? And who sent the message? How? Because you have multiple instances of all those microservices, you have to really coordinate, and the amount of data is huge. So if you want to have, I put the link of the video, it's called à la carte because it's like if you go to a restaurant, you either have a menu where you can choose what you want, that's à la carte. But if you go to some hotel, some high-class restaurant, they don't give you that choice. You have maître d'hôte, which is, this is the menu. I just let you know in advance, but there is no choice. You're gonna have this. And so service mesh is very much a la carte. You can choose which module you need. You don't need to buy into everything. And so the first thing when you build a distributed system is the first one. The network is reliable. That's one of the biggest fallacies. Like, you should not trust the network, that your packet will eventually arrive. So that's why I leave the reference for later, but you can read that RFC, which was written 22 years ago, and they already found out, and those concepts are still valid today. It's really interesting. It's 3 pages long. Like, please, it's really interesting to see. And so to solve those problems about sending message, retries, logging, monitoring, we add code to our system. But what do? Like, we need circuit breaking, we need retries, we need service discovery. How do I know where is that service? And of course, like the rate limiting. Sometimes when you see someone hitting your logging endpoint, you might want to block the IP at some point. But if your service is beyond a proxy, it's the same IP all the time. So actually, someone could block the access for everybody. And so you have a lot of management to do. And all of that is done with libraries or framework, and it's just valid for, available for one language usually. Because once you switch to another language, you have another ecosystem to deal with. So it's really hard for companies that have like 3 programming language in the office to just say, yeah, we're going to do metric and it's going to be all the same. Never going to happen. And so this approach of using code is quite painful because it's not homogeneous. It's not the same everywhere. Some library, some version of library, you have a combinatorial explosion of how many features you have with those library and language and everything. And so to prove a point, can anybody here run the latest library for his network, or does anybody run an older version of the? Okay, yeah, you prove a point. And the thing is that it becomes really hard to test this library and code, and you have to mock, you have to do you have to go through a lot of jumping through hoops before you can actually be sure that what you put in production is actually safe. So yeah, some people are just actually locked into some version of language. Like, even if there is this nice language that solves their problem really fast, they are locked because it's just too much work to migrate. And so when asking the question, what is a service mesh, we have to ask, what does it solve, actually? And it's one thing, communication between services. That's the thing, it's the network. It solves the network. And to give you an image, it's more like a network for services, not for bytes. We don't deal with packets, we don't deal with headers. We deal with just like, I want to talk to somebody. This service want to talk to this one. And so the way they architect it, I don't know if you see back there, is it okay? All right. Does anybody here knows what Kubernetes is? Okay, so that's most of the room. So Kubernetes runs this container. Those containers are embedded into pods, which can be one or more containers. Those containers is a small deployable unit that you can use. And the way a service mesh works is in 2 parts. You have the control plane and you have the data plane. The data plane means they use a proxy in that pod. So all the network, all the requests goes through that proxy. So if service A wants to talk to service B, it goes to the proxy knows where is service B, send it to the proxy of service B, and this delivers the message. So you have an abstraction of your network. The nice things you have with this is that everything goes through that proxy. So you have metrics for free. You know exactly how many requests to where and how far it can go. The other nice thing is that since the whole traffic goes through there, you can encrypt it. So you have actually encryption between your microservices. You can even tell routing, like if you see a request to service B, block it. So you can deny service from some service. And all of that is sent to the control plane. So they call it pilot, mixer, and citadel. In pilot is the one that gives the route. So when a new service comes out, you send a message to the pilot, and the pilot distributes the writing table to all the proxies. The proxies are actually open source. Well, not all of them, but that's the idea. But for Istio, it's an open source project written in C++ called Envoy. I don't know if anybody here heard of Envoy. 1, 2, 3, 4. Okay, there's more. And Envoy was developed by Lyft, and it handles 2 million requests per second. So they make it blazing fast, super performant. The second thing they did is to guarantee that the processing time of a request takes the same times always. Do you understand why is this important? So basically, if you have a performance bottleneck somewhere and you want to find why, and if you have many components, you want to know for sure which one is stable or not, because otherwise you will always ask yourself, is the proxy performant? How long did it take for the proxy to process the request? But if it's fixed, you know actually that the bottleneck is not going to be there. So that's a nice property to have. Citadel is the security service that rotates the certificate, so that when pods come on and off, and after a certain time, the certificates are renewed.
So does it mean, Christian, does it mean that all the traffic of all the microservices go through the single container or a couple of containers? Does it mean that, no, the services talk with each other?
Yeah, but they never talk directly to each other. They talk to the proxy. Yeah.
Okay. We have one proxy for all services, or no?
Per pod.
Per pod.
I can show you actually what it looks like if you have Kubernetes. Yeah, sorry, it's bright, but this is an application I deployed, and you see there is two containers inside that pod. One is the application, the other one is the pod. Is the proxy, sorry. So you see it's super small footprint. It's like 10 megs, so it doesn't take a lot of resources.
So it's another application.
Yeah.
It's like a container for our application. It's not a container.
No, it runs inside the container, but it's not. Yeah.
Are the metrics aggregated by service, or is it
Yes.
by proxy?
Yes, they are aggregated. All the metrics are sent to the mixer, and the mixer can do interesting things with it. Yes.
Just from presentation perspective, it might be more helpful if you say that it runs as a sidecar proxy.
Yes, I can.
Because immediately it makes it a little bit more clear for people.
Okay, thank you. I will keep in mind that.
On the console, they just released a similar feature, console connect.
Yeah.
And when they present it, they always repeat, like, they run it as a sidecar proxy. So all traffic goes through the sidecar proxy.
Yeah, I didn't know if people were familiar with it, so I tried to explain it in very simple terms, like if. But thank you for your help. Is that more question? Alright. So if you look at the network OSI stack, you see that you have the data layer, and if you build a network overlay, it's something that sits on top of there. But that's really low level. And in the cloud, when you're spinning up instances all the time, unless you're an IP table guru that can SSH everywhere and configure IP table and the routing and everything, it's quite hard to maintain when you're in a cloud environment. If you have your own infrastructure and you're running bare metal or something, it might be possible to do that and to route everything. But how long does it take if you create a ticket to open a port somewhere, or to configure? It might take a really long time. So that's another problem. And Kubernetes sits actually in layer 3 and 4. So you have the Kubernetes API, which lists all the current pods running, and the service mesh sits on top of it. Because the goal of the service mesh is to actually implement tags, which sits on top of HTTP. So if I want to call you, I actually don't want to memorize your phone number. I just need your name so I can find your phone number. If I want to talk if service A wants to talk to service B, it's only the IP of service B. Just need the name of service B. So that's the idea here. And when I looked at the first time, I looked to say, okay, but how should I code my application when I want to talk to some other services? And it's actually quite simple. You just give a name. So this is the Python app. I put the source here so you can see, but it's just a name. You give a name and you stick to it. So that name, it can be namespace. Here they make some fancy things so that it's manageable later. But actually, if you want to talk to service, you just name it and you just code it. Yes?
The code you mentioned over there, does it resolve, can you resolve it to the code level also, or is it just...
You can, but it's...
Because in the cloud you probably have dynamic ports.
Yeah, and the thing is that you can map port as well, because it's not... I mean, that's a full IP. Otherwise, if you don't put the port, it's going to be, and you have HTTP, it's going to be 80.
Yes.
So I honestly cannot understand why they put the port. I will try to wrap my head around this application. I just give you the code as I found it. But to me, it's just like you can now hard code a URL into the code and say, okay, I know I don't need to care about this anymore.
So currently in this code is resolving to the IP, not actually the whole endpoint. Right?
Not the service. The service just send it there, and it's actually a DNS request, and so the proxy change it to something that is change it to the IP. And so to give you an example of what it looks like, this is a manifest from Istio website, and you have the spec here. Oops, sorry. And you can see that giving a host, you can HTTP match headers end user, so you have a header that is named end user with the exact of JSON. So that means that you can tag request, HTTP request, and route them to a specific host. Here they say subset v2, because in Kubernetes you can tag, you can put labels on deployment, and usually they suggest that one label would be the version of your application. So actually now you can have more than one version in production to do canary release or those type of things, and you can direct traffic directly through them. Here it says just that the user JSON will be routed to v2 and that all the rest will be routed to v1. So that's it. You have like a super fine grained management of the network. And of course, if you ever had to code the retry logic, does anybody here coded a retry logic? How many of you did those themselves? Not yet? Okay, well I did. So just so you know, it's yeah.
Hundreds of times.
Yeah. So you know that it's not something that is super easy. You have a lot of testing, you're never sure. You don't do that often either, you know, it's not like every day you need to re-implement the logic. So here is just, you add 3 lines of YAML somewhere. So yeah, it's YAML, so you have to get comfortable with it, but I mean, that's the best they could do. And to be honest, the manifest is actually quite small compared to some Kubernetes manifests I saw, or just a wall of YAML. I'm sure that the next guy who's going to come up with a UI to manage those things is going to be billionaire. So, info startup. And on the security level, you can actually define super fine-grained network policies. So, one example is actually mapping to role airbag. You know the airbag in Kubernetes? You have a role-based access depending on who and what. But the most interesting feature is the MTLS, mutual TLS encryption, so that nobody, even if somebody listens to your network, they cannot decrypt your traffic, which gives, for instance, for bank, they usually have hardware doing that job. And those hardware cost a bunch of money, and they can save that. And the second thing is also the speed of development, which is like when you need to open a port, now you have a manifest and you can make a pull request instead of sending a ticket and hoping that someone will pick it up. And then you still have to deploy and test, because oh no, it's behind a NAT or a firewall or something. So there's always this problem with with a fast deployment. Observability. So here they use Prometheus, which is also a cloud native hosted project. Everything, like basically the whole network now is stored into a database, and you can access it anytime. The nice thing with that, you can even have tracing, and I can show you what it looks like. You see that I created a request, and this is what tracing kind of looked like. You can see that this is the main request, and you see where the time has been spent. And maybe if you look at that, you might see, why don't I make the call at the same time to save some processing so that the service can reply faster? Because most of the services have some, I would say, you have to reply under X millisecond, whether it's 100, whether it's 1 second. And that can be a really great tool to help debug.
Is this captured by the Istio framework, or is it a client library that?
No, that's Jaeger. So Istio Istio is the glue of many open source repository. Istio is the thing that manages the fleet of proxy. So with that, you also have because you have all the traffic, you can use tools like Jaeger, because it's just an API. You just say, okay, here's the data, it's formatted that way, please display it for me. So now you have more control over it.
So it means that Istio feeds Jaeger with data.
Yeah.
In that direction, not
Yeah,
in the other
yeah.
direction.
No, it's well, every request is actually gathered by the pilot, and time to time you have like Prometheus that collects all the metrics, and you have also Jaeger to interact. I don't know exactly in what way the Jaeger reads it, because I know that at first they were using open tracing, which is another tracing agent, and so I haven't dig too much into how the tracing worked, because that was not the most interesting part for me. The really interesting part was the security, which is really hard to get right, and the metrics. Those are the metrics that you can see. For instance, this is the name of my service, and I know like how much success rate I have. And you have all those nice graph to tell you, okay, the incoming request, the flow, the number of 400, 500 you get, and that's quite interesting. The nice thing also is when you have to explain to people what is your service, your request look like. You can have those animation that come and read those data from Prometheus or other database managed, also provided by Istio in some way. And so when you need to explain, okay, why is this service not calling this service directly? You know, you can make informed decision about where your service should, if a service should exist or not. And that is much more powerful when you have to architect something. Because most of the time, what it is you have 10 microservices, and those microservices keep on growing until it's become a distributed monolith, and then you think about, okay, let's break it down. But make no mistake, Istio is still like super hard. If you measure the work of going from nothing to Istio, and the work from nothing to Kubernetes is almost the same. So if you don't have Kubernetes, Istio might be just what you need. You don't need everything, but the amount of work is still a lot. Also, some API are still in alpha, so it kind of works, and good luck debugging, you know. So they announced version 1, but I'm still like not sure enough when I see something and I say I don't know if that's the expected behavior or not. I still need to practice it more times.
So here you said that you don't have to use Kubernetes.
No.
You can use Istio in isolation.
Yes. Because actually, the thing is that Envoy is really the core of this. It's the proxy, and it's super powerful. It's super like optimized. The problem comes when you have a fleet of those proxy to manage. then Istio is really helping. The thing is that there are other service meshes that can do that, and some of them has some feature that Istio has, some of them don't. For instance, Console Connect doesn't have the HTTP tags, but it has encryption because they have a big client that is a bank, and they build that first so that they can iterate and on the next. So yeah, yes.
So how does that Istio run containers? You said that we can replace it.
Oh, by the custom resource of Kubernetes. So actually in the, you have namespace in Kubernetes. So you have a cluster. The cluster can be separated by namespace, and you have one namespace that is Istio system. And this is all, you see, you have the telemetry, you have the egress gateway to let the traffic out, and I get Citadel is here, Grafana to display the metrics.
I need a real service, for example, contact service. We have a contact service, and we have a container that contains that service.
No, you don't see the service anymore in that way. Like they are not managed by developer. So now Istio is managed by the infra team, basically.
Yes, but we said that we can replace it with Kubernetes, right? Kubernetes runs the containers.
Yes.
The containers could be, for example, our contact service.
Yes, of course.
How does that Istio run that, or the proxy, I don't know, run that service in the production or in the testing?
Yeah. So if I understand, you want to know how Istio make that connection between services.
No, runs that.
It's not Istio that runs. Istio connects.
So there is a component that does that, right? Or
Yes.
Istio uses Kubernetes in order to run that container.
Yes. Istio is the configurator of the network. That's all it does. Well, you understand what I mean. But it's Kubernetes that solves your deployment. With Kubernetes, you write your manifest, and once you apply that manifest, it go fetch the Docker image and runs it, given the spec, the number of replica and everything you do. So your deployment is fixed with Kubernetes. You don't need to care about it. The interesting part is what happens when you have a new version and you want to, for instance, control the traffic to it. To do canary release. It's very hard to do with Kubernetes. You have to go through a lot of length to find where is the IP, how to route traffic to there. But with Istio, you can do it with the little bit of YAML that I showed you earlier. And you're still interacting. For instance, if I apply a routing rules, I apply it with kubectl. So it's still with Kubernetes. Of course, if you use OpenStack or something else, it will be that. If you use, you don't have to use Istio, you can just use Envoy. And the way it's configured is by HTTP. So you don't actually have files. Because the problem with files is that you need to restart the container and you might lose requests. So it's like directly configurable. And you have also a lot of things to think about, like security, because you don't want funny people to go and change that. Does that answer your question? And so that's the time for a little demo. So you see the service here. And you see the same image here. So the nice thing is that it's language independent. So here you have a Python app that talks to a Java app and a Ruby app, and a Node.js app is in the background. So this is the front page, the product page, that calls the Java application. It's a little different, but you have 3 versions of that Java app, and I will show you in a minute why. The Ruby app provides the details. It's a bookstore, actually. And the ratings for the book are called by version 2 and 3 of the Java, the review service. So I will stop the traffic for a while. So you see, if you look here.
So what do you mean by stop the traffic? You have the
yeah, to have those nice animation, I need to put some traffic in it so that it animates, and
So it's fake requests made by you.
No, it's a real request, but just like I generated.
Generated request.
Yeah, exactly. So this is like a simple book. You have the book details on the left and the book reviews on the right. If you look at here, you don't have any ratings, and I will explain in a moment why. So the red one is version 3, the black one is version 2, and no reviews is version 1, as per this graph I show you. Actually, this graph is more pretty. You see that version 1 here doesn't call the rating here. All right. So I forgot what I was doing. Okay. Yeah. We are gonna lock all the traffic to version 1. So where's my script? Shows. So that's it.
So here you just configured Kubernetes, not Istio, right?
Yeah, actually, this custom resource is an API provided by Kubernetes. Kubernetes allow extension. So Istio comes, create an extension to tell Kubernetes, okay, I'm going to manage those pods.
You mean that the control plane is exposed through Kubernetes?
Yeah, it's called CRDs, Custom Resource Definition, and it's. I haven't looked at the code and how they do exactly because I haven't looked. Sorry, but the thing is that it becomes. I think the demo here is like 5,000 lines of YAML, so it's quite massive in terms of how many things you need to configure before you get everything going. So yeah, this is why, actually I can show you the virtual service. I can show you what I apply so that you see, maybe that would be better. All right, so you see that the API version is managed by Istio, but calls Kubernetes in the hood. It's actually in alpha, so do that. And it's called a virtual service. So virtual service is kind of like the name definition in a discovery, what's it called, the system discovery? Service discovery, thank you. And basically it routes that all the product, if you go into the service product page, you want to go to the version 1 of the product page. Same for all the other service. As simple as that. You have 3 API calls, and that's each one for those service. Is that okay? Okay, let's move on. You can see here that if I refresh, I don't have the reviews anymore. The stars are not showing up. Doesn't matter how many times.
And the architecture graph has been updated as well, or
yes.
One?
Yeah, that's a real request that I just did.
But we only have V1 now.
Yeah.
And why we still see V2 and V3?
Oh, sorry. Last 10 minutes, if I. Let's wait. You can see that these are becoming gray. And now you see the. So it's not a fake demo. Yeah, that's the service graph. Right. So what I wanted to show here is that even if I refresh a lot of time, it's always this. I'm not cheating. That's what I mean. But if I log in.
So here you configured the load balancer itself.
Yes, I locked everything to one version, all the traffic to one version.
But V2 and V3 are still up and running, they just don't
Yes.
receive any traffic.
Exactly. So that's up to you to manage those versions, because now you have control of the canary release. You can automate that, but it might be like for another talk. So here, if I log in as a JSON, here you can see JSON is here. I still don't have the review start. But if I apply the route to tell, okay, now I want the user JSON to be running this, you see that now I'm stuck to V1. And so now, but if I open it as another, of course. Now I'm an anonymous user, and you see that I'm still going to the previous version. So that's why this. Yeah. So JSON came here, so we have some traffic, and the rest is still the other traffic is still working. So that's the more finer grained control of the traffic shaping you can have. All right, so here is the list of all the various service meshes that exist. There is here a comparison between Console Connect and Istio. Yes?
For the user JSON that you mentioned, there's an exact route that says if the header has a JSON value, then route it to this one. Is there any options that says route 20% of the traffic to this space or 80% on that?
Yeah, there's plenty. And some of them are in alpha, some in beta, some are stable.
Okay.
They even have one with a JSON web token. So you can actually decrypt the token to know, okay, this is my user. You don't need to pass a header in, which might be a better option.
Okay. So there's more than this control, like.
Yeah, you define what is the tag, the rules that you want to tag the request with. You can also define the kind of load balancing you want, because a stupid round robin that just puts requests one after another, or you want something that's super hard to do is like least request. I want to send a request to the service that is the less request than the other, so that is the less load, and so you can even out the traffic. It's really traffic shaping in all the sense.
Yeah.
So about this slide, I understood that Envoy is part of Istio, and here it's put in parallel with it. So so what's exactly the
Envoy is like the core of Istio. Istio is the.
Can you use Envoy without Istio?
Yes.
And can you use Istio without Envoy?
No. Right now, no. You have to have a proxy. Istio is not the proxy. Istio is the manager of the proxy. You have a fleet of proxy. If you have 100 microservices, and you have to pod a proxy in each of them, how do you make sure that the routing is in sync?
Yeah, so it's a proxy manager.
Exactly. In simple terms, yes.
So in case of in terms of microservices, that Istio could be called API.
You can use it, but it's a little bit like by default you can use Nginx with Kubernetes as an ingress. So what the traffic comes in your cluster and the traffic that goes out, they usually use Nginx. The thing is that you can actually replace the Nginx with Envoy, which is what Istio does.
There are also some parallel other project that does specialize in using Envoy for ingress that is not
Exactly.
really part of this project, but parallel project as well.
There is this project called Harbor, I think,
Yeah, definitely.
from Heptio, which is a Kubernetes startup, and they are building an ingress controller on top of Envoy. So you see, it's a lot of building blocks that you need to see how they interact. All I managed to do here is to make everything work together by following the docs and trying to figure out what it is, because it was not straightforward at all. I can see, if you manage to follow the doc and have it running in 1 hour, I want to know how you did. So yeah, any more questions? Yes?
So the Istio, is it eventually consistent when you come to deploys of new versions and then the graph needs to be updated in Istio, right? Where the IPs are. So is that, I heard Envoy is eventually consistent. And I just wanted to know from you about Istio, since it's using Envoy behind it. And if it's eventually consistent, you could have stale proxies there that could give you like hyperthrees in the end. So
Yeah, that's what Istio is there to avoid. The way, from what I understood, I'm not sure about it, but the way Envoy works is that to make sure that you process the request for a defined moment of time, it's like an event loop, like Node.js. You know, it's just one thread that's running for the main thread. The thing is that to process all those requests, they spawn out workers, so on other threads. You have to synchronize the route table to all those workers. And that is a very more advanced talk. Like, seriously, it's just 1 hour on that would be too short to talk about it. But somehow, the routing table of those workers needs to be updated. And you cannot block something. That's the goal of the Envoy, is that they guarantee that they don't block anything. So what they do is they use the event loop to synchronize. So by the time the event loops come to process those new routes, you have a moment where the route can be false. And that is the kind of like how you manage the deployment. How do you make sure that you ship the traffic from one to another? The first version, like I started at 0.8, it was not working perfectly, but now it is. I haven't seen a 500 in all the demo and tryout I did. But before, yeah, I could see, and you could see it very easily when the Jaeger UI. But yeah, here I don't have anything that is red. I can check, but yeah, no more traffic, sorry.
So you mean to say that during a deploy, you probably, Istio will handle like those routes that are.
Yeah, now you have to manage the traffic. Like if you want to deploy and have directly the new version, that's a little bit an overkill for Istio because Kubernetes provide that for free. You know, as soon as you have rolling deployment, you don't have downtime. That's the thing with rolling update. You never stop your service from running. But you might still process the previous version, which makes things really hard if you have things like database migration. So it becomes an architectural problem more than a service solution. So that was for service mesh. Any more questions? Do you understand more or less what is a service mesh? What is it called a mesh? Like those mesh thing? Okay. Good. Now we're gonna talk about I talked for 1 hour already. Like that is not 30 minutes. Okay. Now we're going to talk about chaos engineering, which is kind of like this meetup.
Anyway, don't hesitate to leave if you have to leave. Don't feel shy, again, it's friendly.
Exactly.
Julian wouldn't feel offended, so if you have to leave, don't hesitate.
Alright. Do we really make a break or people
No,
want to
just
leave?
call.
Okay.
For you to leave.
So, when talking about chaos engineering, it's really interesting to see that people come out with their own definition because it's basically something that exists for a long time. You can just find a new name on Netflix. And by the way, the team at Netflix has been renamed resiliency engineering. So the weight of the word chaos is a little bit different meaning. But here is the definition from the principleofchaos.org website. Chaos engineering is the discipline of experimenting on a distributed system in order to build confidence in the system's capability to withstand turbulent conditions in production. So basically you want to make sure that even when things don't go according to plan, you still have your service up and running. Also, the Colton Andrus, which is the founder of Gremlin, which is a chaos engineering as a service company, he's more on the not using chaos that much, because it's sort of like it's a thoughtful, planned experiment designed to reveal the weakness in our systems. So chaos is actually a very small part. Like the name chaos came from chaos monkey, which is just kill random instances in your cluster to see how the system reacts. But for most people who, you know exactly what's going to happen if you kill instances in your cluster. So that's not really the point here. The point is to make sure, like, to know what happened when. And that is the experiment. You want to experiment to really make sure that your system the failover of the database work, that the backup are actually can be restored, those kind of things. There is also that Nora Jones, which is a chaos engineer and Netflix, says that chaos engineer isn't done to cause problems, it is done to reveal them. They do chaos engineering because they have this DevOps mentality where you build it, you run it, and so they bring back the problem to the engineer so that they fix the stuff. You know, it's more like, okay, this is your problem now. It's not there is no ops team that's going to come and help you maintain that. Another definition also could be chaos engineering is exploratory testing of non-functional requirements, where non-functional requirements are the requirements that, if not met, render a service non-functional. My reaction exactly. So having a child, chaos engineering for everything in your life. That explains a lot. And what chaos engineering is not. This won't work, basically. This, and they have the saying, like, hope is not a strategy. That's why they do testing. It's funny, but I can feel the pain of some, on-call nights. And so in the code, usually when you build those microservices, there's a ton of code that isn't really tested. For instance, graceful shutdown is really hard to get right. How do you make sure that you drain those requests without giving back the 500? How do you make sure that your health check is actually checking? I saw health check that just was, yeah, the service is running, but it's not connected to the database. What can I do? And so things that are super hard to find out is cascading timeout. You have a timeout somewhere, usually because you're using a library that is, for instance, the client to the database. And there is a default timeout in there that nobody knows or nobody ever thought of overwritten and to override. And so you have something somewhere that blows up and you don't know why. And those are really hard to find out. And of course, like, how do you know that your deployment is actually safe? I have a war story where we were running this massive MongoDB cluster, and we had to upgrade a part of the schema. It was not much, but just adding a field somewhere took quite a long time. And the thing is that with Kubernetes, you have this readiness probe that is set for 30 seconds. You can set the field by yourself. Then the engineer that made the work really worked well because he was like keeping on the, what's the name of it? The index, the pointer to where it was in the migration so that you can resume and just like, in case it failed, you can still manage. And he did a great work, except that nobody thought about that readiness probe. So it took so long for the service to get up that Kubernetes was killing it. So it's not coming up, And so you cannot think of that in advance. You have to burn yourself. Hopefully we tested before, so we knew what was going on. But we didn't test it with enough data for the readiness probe to kick in, to see timeout. And so, yeah, we had to run it many times, and it was quite painful. But that's the kind of thing chaos engineering can help prevent. Because database migration, I do database migration twice a year, basically. I know, like, it's super hard, it's a ton of code, it's a ton of tests, and a ton of time for me and brings zero value to the business. It's not like yeah, I have new feature. No, I just have the same with a different database. So that's kind of painful. And you have different type of errors about what happens when a service is unreachable. How when it's actually reachable but reply later, or when you have too many requests at once, and you want to mitigate the back pressure and all those things. Migration are a big pain. Like changing the database schema can be really hard because now we have rolling update and you don't have downtime. So you have to maintain, you have to write code that works with both versions of the schema of your database. And once the data are migrated, you have to tear down and remove that code. So you're always writing two horses at the same time. And that's true for most of the development time. And so that's why Google wrote a book called Self-Reliability Engineering. And it was, the people that are SRE are very much like working to identify weakness and improve resiliency of the service, which is where I put the link because it's really interesting if you want to read that chapter. It's a book that is separated, it's free to read on the internet, and the chapters are quite isolated from each other, so it's a really recommended reading. So the SLA is this. These measurements describe the basic property of metrics that matters. So that's the SLI, service level indicator. The service level objective are what values we want those metrics to have. So once you find the metrics, the key metrics, what values those metrics should have, and then you have the SLA, which is the agreement, and that's the contract with your client, the customer, basically saying like, what do we do when we don't reach those numbers, which is basically money. So those things have really big business impact, and have impact also in the sense that chaos engineering is there to help evaluating the cost of downtime and reducing that downtime as much as possible. And so we have these things in the chaos engineering community called game day. So they say, okay, that day we're going to test this in production, and you can answer like what happened when. And there is this really nice article by Gremlin on the blog post. And they put how to break this DynamoDB. You have to know that, I don't remember if it's in that blog, but DynamoDB can scale up, but cannot scale down. So if you scale up too much, you have to migrate your data, otherwise you will be stuck with a big invoice from Amazon. And those kind of things are interesting to be tested. And that's the role also of chaos engineering. That's the kind of information chaos engineering can tell, okay, yeah, we can scale and we can migrate in case something goes wrong. It's a lot of reassurance that we know we can withstand those turbulence in production. But chaos engineering is also a way of, it's from the organization. You cannot have chaos engineering unless the organization is doing chaos engineering. It's like fire drill. You want everybody to participate. We do that, it's boring, but in case of fire, everybody knows what to do. You know, it's like we're even laughing about it, but it's true. And that saves life. And so the organization start by saying that a failure is something we need to learn from, not something to be punished. Because if the IT fail, probably the business fail. If the business fail, well, IT fail double time because everybody is fired. So yeah, there is a lot of things, and for instance, to see what is the name of it, the health of the organization compared to chaos engineering, you can see what is if you have an incident management program, like how do you rate how bad things can get? Usually it's by downtime and by they name it for severity. They classify them by severity. So usually a sub-zero is really impact the business directly, so that you're losing money. And sometimes, for instance, at Unity, that's that many requests per second that we didn't display ads, that many dollars. it was a very clear and usually a very huge cost. So those kind of things are worthwhile to know what you should do, who should be updated, because they probably have to make decision about which service they can turn off or what to do, because there is actually handling money. And it's very much a practice approach. Like if you do it one time, it's okay, you did it one time, congratulations, is your gold star, and you pass the test. But it won't make it any better in your organization.
But you get a certificate.
Yeah, exactly. But I mean, even if you just try to restore your backup and see if they work. You don't know how many times I say, oh, the tar JZ is corrupt. Too bad, you know. That's your data. That's and it's simple, but not many people do it. And so that's why chaos engineering should be in the culture of the company. You should enforce those things and reward them. And so the funny thing is that since chaos engineering is not new, you can see the Toyota assembly line. They had this unknown cord that when an employee noticed a problem, they just pull the cord. The manager on the site come and find out, and if there is a real problem, he just stopped the whole line. And that was a lot of money as well. Like that means that they have that many cars to produce every day to be competitive. So, but every problem got fixed. And that's how you do chaos engineering. You just improve. And it's the Kaizen mentality, which means, but if you separate the word is change good. So improvement, continuous improvement, the idea of, okay, we're gonna learn from it, we're gonna fix it, we're gonna improve on it. And that's how you get better and better at your service. So yeah, the chaos is something that sounds really cool for you and your colleagues. Your boss, if he never heard of it, he will not appreciate that at all. I tried. I just, by experience, resiliency will take you further. That's what I'm gonna say. And the fact that also the Netflix, who came up with the term, just changed the chaos engineering team to resiliency team, says a lot. Like, there is a lot of, people don't understand what chaos engineering means. It's scary. So resiliency, they understand, okay, my system is going to be resilient. I can sleep tight and it will keep on running. So that's money to them. It really helps. And so yeah, if I had to lay out like the step to chaos engineering, is first don't mention chaos.
Yeah, so that's very important. So the first rule as this meetup is that you don't talk about this.
Exactly. First rule, fight club. Exactly. The thing is that you have to set up monitoring, because if it's not measured, it does not exist. That's it. It doesn't matter what you do. You cannot convince, it does not exist. The thing is that you have to identify some of those metrics and consider them like steady state. You know, if you look at the graph, after a while, you kind of know, you get a feeling of what the curve should look like, you know, and you can form an hypothesis on top of this. And once you have that, you can simulate like a real world failure, but of course, I hope you have planned some fallback or some to stop the attack, they say. And the super important part is to write a report with your findings. If you have a document somewhere, it doesn't need to be big. You have templates all over the place on GitHub and stuff where you can actually come and write a little bit, few lines to explain what you did, what you expect, what you see, what it fixed, and what it didn't fix, or you know, because sometimes knowing that something works is actually a good thing. If you don't learn anything, that's good. If you learn something, that's something you need to fix. And if you find like 50 things to fix, probably nothing will get fixed. You need to prioritize those. And so that's why the organization needs to be involved, because those might be like impact the business more or less. And then you can talk about chaos. Say that's because we did chaos engineering. And then nobody will be scared of chaos. So actually you can talk about chaos after you do chaos. And then it's practice and improve. And so yeah, we are gonna try another demo we're gonna try to inject a delay in the user JSON's request. Maybe I can show you what the YAML looks like. She seems to like YAML. So it's exactly what, well, not exactly, but it's more or less what I showed you in the slides earlier, is that for the user JSON, inject a fault, delay for 100% of the traffic, and delay the request by 7 seconds. I mean, this just blew my mind the first time I saw that because it was so simple, I could not believe it.
So here, this is part of the Istio API, right?
Yes.
So in the Istio API, there is this concept of fault.
Istio will see that, yeah, it will see the fault. It will tell the proxy inside the pod, okay, delay that request for 7 seconds.
So which means that Istio is
The
a
orchestrator.
tool also for chaos engineering. It's a competitor of running, for instance. Yeah, they provide the same.
You can call it that. It's not built for that. It's so much wider.
It's built for this. You see, in the API.
Yeah, that's why I do the talk. But the main feature they have is not chaos
It's a
engineering.
main feature, but, okay.
It's like, it's not the selling point.
It's not the main feature, but it's a built-in feature.
Yeah, and very nice one actually. The other thing should, too bad those other people left, but the nice feature about Istio is you can do dark launches. So you can actually mirror traffic. Just imagine you have the traffic from production and you want to test the load on a side cluster. So you can actually mirror the traffic, and the way mirroring works is that all the answers are blocked. So even if the answer come from the test cluster, they are not sent back to the client. But you can copy request, see how the service works, and you can have like real traffic. You know, that's a little bit how Facebook did is Messenger. From one day to another, they just flipped the switch and they had like, I don't know how many million users using their chat apps without a problem. Because they gradually injected those requests from the user. So they could actually test way before the product was up and running into the people's browser. So this has a lot of possibility. Yes?
Or the more faults you can inject. I mean, the way is nice, but disconnects or...
Yeah, you can just say, okay, 40% of the traffic, drop it. Just, I'm sure
packet level or request level HTTP?
Sorry?
TCP packet level or HTTP
Well,
request level?
it depends what you use in your match clause. So, possibilities are very much open. So yes. Now what happened with my JSON? You can see that here, let's call the network. So you see here the service works really well, but if I am identified as JSON, you can see the request is stuck. And after 7 seconds, the request will be processed, and you see here, error fetching product review. So that's a really nice way to test, and you have the blast radius, which is like the impact on the system to one user. So you can say, okay, we can see what happened when this service goes down, what do we show to the user, which is basically what Netflix does. They test that to see, okay, we don't show recommendation, we show the most recent today or the most viewed last month. And that's quite super nice for just a little bit of YAML and a lot of configuration in Kubernetes.
So here it means that the timeout of your Ajax request is lower than 7 seconds.
No, that the request was delayed by 7 seconds.
And
from the server side.
In your app, you have a timeout which is 5 seconds before showing the...
No, in my... Yeah, exactly. In the app, in the service, there is a timeout, which is, you can see here. It's actually quite nice with colors and stuff. I think that those people, they nailed it. But you see, like, this is quite impressive. I mean, how many like we look at terminal and logs and everything, and suddenly you have a beautiful graph that you can show to everybody. Like,
Is it scale? Is it also that nice when you have 300 services?
it is built for that.
It is.
Yeah.
Then
Actually, if you have only 10 microservices, you're gonna do more work than this can afford. It's really like if you have a lot of microservices, this is coming handy. Otherwise, it's just too much work. I would say it's my personal.
Did you have experience integrating this tool with services built into AWS or Azure? So, because I mean, if you host your own containers, sure. I mean, you have on-prem, on bare metal, or virtual machines, of course. Then, but if you're using like naturally the self-managed services, I'm talking like about Azure Functions or Google Cloud Google Cloud Functions or AWS Lambdas, or there's Lambda, meaning that your business logical code runs on a managed fabric. So you don't have control over the whole environment. You don't have containers because you're using.
No, yeah. Here is currently this stage is just the Kubernetes cluster that I created. But I use the Google Cloud. You know, when you subscribe a $300 credit, and you can create it's called JKE. So you have a Kubernetes cluster. It's pre-installed Kubernetes, and then I could install Istio much faster. Otherwise, I have to run props or whatever tool or Ansible to just provision the whole machine instead of the cluster. But for now, if you look at something else, like it's called Knative. I think I have it here. Yeah, Knative. That's a project for created by Google, and it's Lambda function, well, serverless function on work directly embedded with Istio on top of Kubernetes. So with that, you have Istio included, which begs the question: what happens if you already have Istio and you're trying to install this? It's also a lot of configuration, and I'm not quite sure. It's not like super mainstream yet, but you can have. It's just Istio manage your cluster. They can manage multi-cluster, but again, that's a lot of configuration. But Istio.io, you can see they have for Kubernetes if you want to use Nomad. Yeah, enable multi-clustering. That's it. They don't have AWS yet because it's a joint venture between Google and IBM, but that's mainly the first one that are supported.
Another option you have, if you keep in mind that Istio relies on voice as archive proxy, what you could do is you could have a dummy service that basically proxies traffic towards your hosted service. So for instance, you want to have a database in a graph, and then you can have a code that simply just redirects the traffic to the database, and you run Istio there. In this case, you represent the database in your architecture. But then you will have to count for the delays that are those.
Yeah, there is also well, if you use serverless, the main problem they have is that if you connect directly from serverless to a database, what happens if the auto-scaling is too big and you just hammer your database so hard? So there is still a lot of best practice to figure out with serverless. I would say that it is complementary rather than just the all-in. You can, but I would say containers are still have some place if you have like more advanced service. Well, here are all the resources I give you in the slide, and thank you very much. If you have any question.
Does Istio sidecar run on level 4 or 7? As I understood it, when you rule with the headers, then it's 7. Right?
That's the routing, but we hooked it on the level 4. So you need some place to sniff the traffic. This is annoying, this part. But yeah, so you have it. The reason it's in the pod is that the pod share the network and the file system. So for Istio to be able to hijack the traffic, that's why there's one proxy per pod.
Alright, so Envoy actually runs as L4
Yeah.
proxy.
And you can see actually envoy proxy.io. There is a talk, I put a talk in the list of the creator of Envoy, and if you want to know more about it, because I think that's the core. Yeah, I mean, without Envoy you don't have Istio. This is a really interesting project. Where is? Yeah, there is so many features. I'm not sure even where to begin to look for that, but you can check the Get Started. Yeah, and 3 or 4 filters. So there's a lot of reading to do about Envoy. They have a conference now dedicated to Envoy and Istio and Kubernetes. So all of them together are quite, I would say, popular. They are trending now, but there are still a lot of questions to how to set it up and how to manage after a while. So
I just also want to add that there is another project called Ambassador, which actually also built on top of Envoy, similar to Istio, but for another purpose, for the API gateway implementation. So Istio is, like, as they say, north-south routing.
yeah.
It's actually east-west, like for horizontal between services, while Ambassador can serve as a replacement for ingress, so it serves the external traffic from outside into your cluster. You can use it instead of ingress controller, or for API gateway.
Yeah, that's really interesting. Thank you. I didn't know about it.
So yeah, we can see that Envoy is used as a building block in more than one project.
Yeah.
Yeah, probably because it has a clean API to discuss with.
Yeah, they seem to have a lot of. Well, basically now Kubernetes is becoming the de facto platform for deploying apps, and so any company just build like tools on top of it. So I would say that if you build the infrastructure on top of Kubernetes, you're kind of safe because you're gonna find a lot of projects are popping up. There's a lot of startup built around it. So I mean, if you're interested into scenes here, and I think it's the landscape. This is the Cloud Native Computing Foundation. They host all the open source products and they make sure that they are open amongst cloud providers. So you can actually, the two projects that graduated are Kubernetes and Prometheus, and that assure that depending on the cloud provider you use, the workload will be the same on another cloud provider. So, I don't know if Ambassador is there. Yeah, it is there.
Very good. So it was a very, very nice meetup. Thank you again, Julien. So Julien will post his slides on the meetup page. We can continue the conversation.